Before we begin, I would like to mention a couple of agenda. So first we have the project goals, and it's to create an entire ETL process in a database and a Power BI dashboard to utilize the sales data and achieve below objective. Identify core KPI such as total sales, total profit, profit margin, total orders, and profit quantity. And then analyze the sales trend, focusing on key metrics of sales revenue, numbers of orders, and average order value. Identify product performance by analyzing different products at regional level and transactional status. And then create a machine learning model. Create a model to predict when an order will be shipped after it is placed. And then the metrics that we are going to need is the total sales, total profit, profit margin, total order, total quantity, and then the shipping days. Okay, now we are in the SQL Server, and make sure that you save this server name, because we are going to use this server name in order to connect the SQL Server with the Power BI. So you can just write this down on a paper, or you can just copy and paste it in a notepad. Just make sure that you save this server name, okay? And then we can just click connect. Now we are inside our server, and you can click new query to create a new query. And then let's create the database. So we can just create database and the name of the database that we want to create. So for me, I want to have db_superstore, and then you can just click execute, and now it's complete. And once it's complete, you can go to databases here, and then we can see the database is already created. Now we need to have our data inside, and it will appear inside of these tables. So right now we don't have any data at all, so let's just click this db_superstore, our database, and then go to task, and then you can go to import flat file. Now once you are in the import flat file, you can just click next, and then you can just import the data that we need. So I'm just gonna click browse, and now this is the data that we need, which is the superstore.csv data. You can just click this, and then let's name the table as STG superstore, and let's make it small, STG superstore. So STG stands for staging, which is kind of like the original data or the raw data, because we want to make sure we have the original data in our database. Okay, so let's click next, and then you can see this is our data. This is the data that we are going to use, and then you can click next, and you can just click allow nulls. Okay, we want to make sure we get every data, and then we can click next again, and then click finish. Okay, we get a warning here, and let's try to see the warning, and it's the up to 1 cells of data may have been dropped during insert from the following columns, which is profit. Okay, so we probably having a null data inside of this profit column, and we're gonna check this later on. But for now, let's just click close, and we can go to here and click refresh, and we can just check our tables, and there you go, we have our data inside our database. And so now let's create a new query, and let's try to check what the data looks like. So we can just go to select everything, from, and it's going to be stg underscore superstore, and let's execute. Okay, so this is the data that we have. We have row ID, we have order ID, we have order date, ship mode, custom ID, customer name, segment, country, city, state, postal code, region, product ID, category, subcategory, product name, sales, quantity, discount, and profit. Okay, so let's now start to have a little EDA, a simple EDA or exploratory data analysis. So what I want to do is I want to find a couple of things. I want to find the total of sales. I want to find the total of profit. I want to find the profit margin and the total orders. Okay, so this is pretty simple select function, so we can just start. So let's first try to find the total sales. So it's going to be select sum of the sales. Let's check the column. The sales we did like this, and let's call it as total sales from stg underscore superstore. Okay, it should be underscore. Right, so now we can execute this, and this is our total sales. And we can use this value to confirm our Power BI dashboard, because in the Power BI dashboard we also going to have the total sales, the total profit, the profit margin, and the total orders. So we can use this value as like a check, like a validation. So let's see how much is this. So we have 1.13 billion. Okay, so that is the total sales. That's the total sales. Now let's find the total profit. So let's go select the sum of profit, and let's call it total profit from stg underscore superstore. Okay, and let's put a semicolon right here, and then semicolon right there, maybe like this. Okay, let's put semicolon here, and let's execute this one. Okay, so for the profit we have this amount. Let's copy it, and then let's see how much is this. So we have 1.8 billion basically for our profit, total profit. And now let's find the total order first. So total order is equal to select the sum. Okay, so the order is actually not the sum, it should be count, right? Because total order is not the total quantity of the product that was being sold. That's different, right? So the total order should be count distinct of the order ID. From STG underscore superstore. So this is the total order. Okay, let's execute, and then we have this amount of total order, which is 5009. Okay, so 5009 as our total order. And then finally we need to find the profit margin. Okay, so in order to find the profit margin, let me select this first from STG underscore superstore. Okay, so the profit margin is going to be the sum of profit, right, divided by the sum of sales, because sales is a revenue and profit is our clean revenue. And then let's put it in inside like this, multiplied by 100% as profit, and let's call it margin. So this is the profit margin formula. So now we can execute this, and we get this amount of number, but I don't want to have this amount of number. I wanna have something like so let me round this number. So the number should be from here. Let's round into 2 decimal. Okay, let's execute again, and we have 2 decimal point. Now I also want to have a percentage symbol, so let's do concat, and let's add the percentage symbol. Okay, and then let's execute this. Now for this we have this one. So the profit margin is 159%, which is I don't know, it's kind of a lot actually. Now I also want to find the monthly performance trend. Okay, so how can we find the monthly performance trend? So first of all, let's select the monthly data first, right? So in order to select the monthly data, let's just go to select, and let's select from STG SuperStore first, and then I want to have a monthly basis total sales. So in order to do that, I need to use date trunc function, and I need to have a monthly base date, and we can get the date from the order date. Okay, and let's call this as sales month, and I want to see the total sales for each month, right? So I'm going to sum the sales as total sales, and because I'm using an aggregation, I need to have a group by, and it's going to group by the date trunc of month from the order date. Okay, order date. Okay, now let's try to execute this and see what we have. Now this is what we have, but as you can see, it's in random order. We have 2015 and then 2017 and then 2014. So we need to order this salesman by the salesman, but we can do that later. Yeah, we can do that later, because right now what we want, we just want the total sales from each month. Okay, so now we get those value, and let's use CTE to save this table, and let's so I'm gonna call it monthly monthly data as CTE, and then it's gonna put it like that, and let's put a semicolon right there. Okay, now after we get the monthly data sales, I want to get the month before for each month. So basically, for example, I have this column of sales month and the total sales, but I want to have another column, and this column is basically the total sales from the previous month. So for example, this is 2015 in April. I want to have the 2015 in March, so the previous month in here, okay, in the next column. So how can I do that? I can use the lag function, but before we can do the lag function, I want to have every data from my CTE, from my monthly data CTE, and it's going to be the sales month and the total sales, like that, and it's going to be from the monthly data, right? And now let's put a comma here, and then we lag the total sales from previous month. So remember, the total sales is the sum of the sales, but I want to have the total sales from the previous month, so that's why I have this one right here, and this one is the sales month, right, over sales month. But remember, when we let's see our sales month, it is in a random order, so we need to have order by sales month. Okay, so now, like for example, I don't want to have 2015 in January, and then here I have 2015. I don't want that. I want to have 2016 in December, right? So that's why we have order here. Now let's call this as previous month sales. Okay, and we can actually try to run this. Okay, now we get a table, and now as you can see, the salesman is in order, and I have the previous monthly sales as a second column. So for example, in February 2014, I have 800,000 basically, and then the previous month sale is more than that. So this is from the total sales in January. This is from the total sales of February. This is from the total sales of March. This is from April, and so on and so on. and because we don't have the previous month for 2014 in January, we get a null value. Okay, so that's our previous month sale. And as maybe you can guess what happened next. I can find whether how much I lost money or how much we increase our total sales, right? So let's put this inside a CTE again, and let's call it like data as, put it inside. Now I want to select the sales months, and I also want to have the total sales, and also of course I want to have the previous sales. And now I want to see how the difference value between the current month and the previous month. Okay, so I can just do total sales minus previous month sales as difference sales. Okay, and I'll go take this from the lake data. Okay, now let's try to run this. Okay, now I have the difference of the total sales, and as you may see, we have a lot of minus, which is the down. So this data seems like pretty oscillated. We have a lot of revenue. We have a lot of increase and decrease in our sales. So let's after this we can actually create the growth percentage. Yeah, the growth percentage. I can have something similar with the profit margin, but right now I want to have my total sales minus the previous monthly sales divided by the previous month sales, something like that, and then I want to multiply it by 100, and I want to have a round number of 2, and then of course I also want to have a percentage symbol, something like this, and let's call it as growth percentage. Okay, let's try run this. Let's execute. Okay, so now we have this value, so we can see the growth percentage of each month based on the previous month. Okay, and the last thing I want to do is I want to have a status name, like whether the sales is increased or whether the sales is decreased. Okay, so in order to do that, I can use case, then so not then but when the case when the total sales, the different sales, when the difference of sales is more than 0, then it is increased, right? Else, which is the negative number, because it is less than 0, let's call it is decreased. And we can end this and call it as monthly growth status. Okay, and then let's do a group by. So it's going to be grouped by sales, month, and then total sales, and the previous month sales. And let's execute this. Okay, now we can see that we have a lot of decrease and also we have a lot of increase. It is a very fluctuative sales data. We have increase, decrease, 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 and then increase again, and then increase, decrease, decrease, and then increase, 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 increase. So it is very interesting data. And I guess, okay, so that is the simple EDA that we has done. Okay, so now I want to find the null and the duplicates inside our data. So I already have the program, and it is quite simple. For null, I can just do a sum, and for example, for each row, I can sum the null value. So for example, in the order ID column, if I found a column that is null, then just give it 1, else 0, and then I can just sum the null value. Okay, because I have 1 here, and I just sum everything. So let's try to execute this data. Okay, so now remember when we have a warning when we import the data, and it said that it is in a profit column, and it is correct. It looked like we have a null inside our profit, right? So now let's see the null. So let's select everything from SHapley_SuperStore where the profit is null. Okay, so this is the column, not the column, the row where it has the profit is null, and it's in the row of 7,345. Okay, so we found the missing profit null, so the missing profit value. Okay, so that is the null. What about duplicates? We also need to find the duplicates, and you can just do this. You can just select and then just write every column, and then finally count everything, count every column. And you need to group by, because we're using the aggregate function, which is the count. We need to aggregate everything that you have here, right? And when the count is more than 1, it means that it is a duplicate, because when we count everything and we are using the group the group by, it needs to have a difference value for each row, right? For each row you need to have for each row they have different columns, and inside of the different column they need to have a different value for each row. Does that make sense? So let's just try to execute these duplicates, and let's see if we found a duplicates. Okay, so we found a duplicates. Okay, now so we have two value here, and let's see the user ID is something like this: the order date, the ship date, the postal code. Okay, so let's find the duplicates. Let's try to find the duplicates. So here we can select everything from SHapley-SuperStore, where I might use the order ID, so I can just copy where the order ID, like this one. So let's execute this, and we have 4 row, and then let's see the column that has duplicates. And okay, so this is the column that has duplicates, right? It is in row 3406 and 3407, so it is a duplicate, and we can just remove one of this column. So I'm just going to choose to remove this column, and yeah, I'm gonna remove this column, this one column, because it's a duplicate. So how can I do that? And also I want to have a view table, so let's clean while creating the view table. So it's going to be like create view, and so the name of the table, create table, and it's going to have SuperStore data, and it's going to be from, not from, but create view as because this is similar to creating a CTA table. As select everything from SHapley-SuperStore, where the row ID where the row ID is not so this is an integer value, is not this value. So I'm going to remove this row ID, this entire row, and the profit is not null. Profit is not null. Okay, so I'm gonna put a semicolon right there, so remove that. Okay, so let's try to execute this, and okay, so we successfully create the view table. Now if you go to here, this view table, we can see our view data, right? And we can check by select everything from the view SuperStore data. Let's try to execute this, and this is our data that has been cleaned. It has no null value or nor the duplicate value. Okay, and we're going to use this as our data inside the Power BI. So now let's connect the Power BI with the SQL Server. So we can just click the blank reports, and inside the blank reports we can click get data and click the SQL Server. Now let's put our server name here, which is the name of the server that I told you to save, and then let's just click OK. Okay, now we are in the navigator, and let's click the US-SuperStore here, and now I have my view SuperStore data, which is the data that are already cleaned in the SQL Server. So let's check this, and we're going to use this data inside our Power BI, and then let's just load the data inside our Power BI. Okay, now we are inside our Power BI with our data here, but before we do some design, I would like to enter data and create a table called measurement table, and click load, and inside this measurement table I'm going to have a lot of measurement. So let's create a first measurement, and it's going to be total profit, right? So the total profit is basically the sum of the profit. Okay, and then let's click commit, and then create another measurement, and it's going to be total sales, and the sum of the sales. Click commit, and then create another measure, and it's going to be total order. And remember, the total order is count, but we need to distinct all of those order ID. So we are going to use distinct count for the order ID. Okay, and then let's click commit, and then create a new measure again, and it's going to be the total quantity, and it's going to be the sum of quantity, and it should be right here. Okay, so next we can create a new measure, and it's going to be profit margin. And what is profit margin? Profit margin is the percentage of the divide between the total sales divide between the sum of the revenue, and here we have sales, with the sum of profit. And where's our profit? There. So yeah, the profit margin is the percentage of the revenue or the sales divided by the profit. And let's click commit. Okay, so now we have all of this measurement. So let's create a card. Okay, I'm gonna do this. So maybe this big, and this is going to be the total profit. Okay, now this is our profit, and I want to make it small, maybe something like that, because yeah, maybe something like that. And then I'm going to copy all of this, just copy, and then okay, so that's the original, so this is the total. And let's use all of this. So the total profit, so let's remove total profit, and then it's going to be total sales. This one is going to be the profit margin, and this one is going to be the total order, while while this one is going to be the total quantity. Okay, and okay, I'm trying to make it like this, so this one can be right there. Okay, so this is our basis Power BI. So we already connect our BI, and okay, so let's design the Power BI. Okay, so we are going to design our Power BI, but before we design our Power BI, I forgot to change the data type from general to percentage. So this needs to be percentage because we are searching the profit margin percentage, and the profit margin percentage is 62%, almost 63%. So it's really good margin profit. Okay, so first let's see what we can do. I can get stack bar chart, and let's put the stack bar chart right here, and inside the stack bar chart I'm going to have profit as my x-axis, and the y-axis is going to be the category like this. Well, not category, maybe subcategory. Yeah, let's do subcategory like this. Okay, and let's copy this and then put it here. Okay, so maybe something like this. So for this part, instead of category, I want to have region, and instead of profit, I want to have sales. Okay, so this is region by sales. And for this one, I want to have a filter, and I want to have a top 7. A top 7 based on the profit. So let's drag here to by value and then apply the filter. Okay, so now I have my profit by subcategory and the sales by region. Okay, so let's try to design this first. Okay, so first of all, I want to have the bars to have a color purple, maybe something like that, and I want to remove everything. I want to remove the grid line and also I want to remove the title from the both axes, from the y-axis and from the x-axis. Remove the title, and then for the values I want to have a thin, and it's going to be dark, or maybe no, I want to have for okay, so for the value in the x-axis I want to just remove it, while the value inside the y-axis is going to be thin, and I'm going to choose a dark, a black color, and then maybe okay, this looks pretty good. Okay, so now I want to go to general and go to title, and of course I want to have a background color, and the background color I maybe wanted to have something like this. And okay, maybe something like this. Okay, so let's add an effect also, because I want to have a rounded corner, and so the visual border is on, but I want to have a white color, and the rounded should be 15. And okay, so this is our stack bar chart. Now let's change the title for each one of this. So for this one I want to have a profit by subcategory, and let's have 18, well 16, no 18, yeah 18, and then let's put it in the middle, and let's do the same thing with this. It's going to be 18, let's put it in the middle, and this is going to be sales by region. Okay, I guess this seems pretty nice. And also, okay, I want to modify my KPI card, and let's have something like let's go to effect, and then go to visual border, and I want to turn on the visual border, and let's use a color of purple, just the same color as our bar, and let's also round the corner into 15 pixel, and then the width is maybe 3, and let's make the Colab values a little smaller, so maybe something like 30. Yeah, we can do 30. And then okay, let's go back to general, let's go back to effect, and then let's add a shadow, just a little shadow, like maybe something like this, and let's use the position of the shadow into the top right. Okay, and for the category label, let's have something or thin, and let's have something like maybe 20 or maybe 18, 16. Yeah, that seems pretty good. And let's change the color into also purple. Now I want to have to change the property, and the height is 120 while the width maybe 150. I don't know. Yeah, let's do 155 maybe. Let's go back to, okay, so for this one the name should, let me remove the percentage, and then should be like that. And okay, so maybe I need a bigger or maybe a smaller color value. Okay, so for this one, I want to change the name to something like that. Yep. Okay, should I change the color of the value? Okay, I don't think so. I think it's pretty good. And let's try to adjust the position of this KPI card. Maybe something like here, something like that. Maybe like here. Yeah, it seems pretty good. Yeah, I think it's pretty good. Now I would like to have, let's create a matrix, and inside of this matrix I want to have a category, and for every category I want to have the subcategory. Okay, and of course I want to have the total sales. Let's go to sales as my value, and then the profit, and then the quantity. Where is it? Okay, so let me down here and then go to quantity like that, and then let's put this something like here maybe. Yeah, something like this would be nice. Okay, so and let's open the category. So it's going to be the furniture, and then this one is going to be the office appliance. And now we have something like this. And okay, I also want to change this into, instead of sum, I want to have a total. So this one is also total, and this one is also total quantity. Okay, and let's make it bigger. So for the values, let's maybe 11, 12. Yeah, maybe 12. Maybe 12. Yeah, 12 is good enough. Or you know what, what about 13? Okay, you know, let's do 13. So this is going to be our matrix. Let's make it bigger. Yep, something like this. Now I also want to have a line chart, and inside this line chart it's going to be something like here. And for this line chart, the y-axis is going to be the order date for a monthly basis. So it's going to be the year and the month, and I want to calculate the sales over month. Okay, I made a mistake. It should be right here in the x-axis. So this is gonna be the year and the month, like this, and it's going to be the sales, the sum of sales. Okay, so we have something like this, and again I want to remove everything. For the x-axis I want to remove the title, while for the value I want to make it into a din, and then it's going to be maybe 12, well, maybe 10, and then the color is dark. Okay, maybe something like that. While for the y-axis, remove the title, go to value, change it to din, let's have a 11, and the color is dark. Yeah, something like this. And for the title, I want to have sales over time, and it's going to be 18, just like this one. And then the color, background color, is going to be this one, and let's put it in the middle. And then we can go to effect and turn on the visual border. Let's make it 15, and the visual border is going to be white, and yeah, something like this. Now we have something. Let me adjust the position. Okay, so something like this. Okay, and now after I'm having all of this, let me add maybe a pie chart. I want to have a pie chart for the city. So first of all, okay, where is the city? Okay, so the legend is obviously for the city, and the value is maybe profit. Go to profit, and let's go to filters, and let's do top 10 or maybe top 5. Let's do top 5 by the profit, and click apply filter. And okay, so let's move the legend into the top center, and we create something like that, and make it black, and then have a din, something like that, and then make it bigger a little bit maybe. And the title, let's go to the title, and okay, turn off the title for the legend. I'm gonna turn it off, and then go to general, go to title, and the title is top 5 city by profit. Nice, and it's going to be 18, and it's going to be black color, and we need a background color, this one, and put it in the middle like that. Okay, now okay, I also want to remove let's see the detail label. It's maybe I'm gonna make it dark. The font is going to be thin, and let's make it a little bit bigger. Make the smaller, maybe something like this. And for the general, and let's add an effect of rounded corner. So the visual border is going to be on. The rounded corner is to be 15 pixel, and the color is white. Okay, so it's going to be something like this. Yep, something like that. Okay, so now let's close this, and let's add a ribbon chart here, and I want to have a ribbon chart for the profit and the discount. Okay, so the y-axis is going to be profit, and the x-axis is going to be the discount. And we have something like that, but as you can see, okay, I'm gonna make it bigger first. Okay, so this is basically discount and profit relationship, and as you can see, we have a very interesting data here, and it is start from discount number 10. Maybe we can focus on this part by doing filter. Let's go to discount, and let's show something that less than 20 maybe, or maybe 15. Yeah, maybe 15. So something like that. And now again, let's remove everything. I want to remove the grid line, and the for the vertical, also for the vertical line. And then I can go to ribbon, well, not go to ribbon, I want to go to the column, and the color is, again, let's do a purple color, and go to general, go to title, and it's going to be profit versus discount, and it's going to be 18, and the text color is, well, the text color is dark, but I want to add a background color, and it's going to be this one, and let's put it in the middle. Okay, and let's go back to visual. I want to make the value darker, and the font is going to be thin, and maybe 11. 11. And then let's do that to the y-axis. So it's going to be the value of 11, and that's going to be thin, and the color is black. Yes, we maybe something like that. Have we add the data format for this one? Not data format, but effect. Okay, so the visual border is going to be 15 pixel, and the color is going to be white. Okay, so now we have something like this for our dashboard. And of course I would like to add some filter around here, but before that, okay, let me make it this yeah, no, it's a bad idea. I want to make this smaller. So that I can have a space here for my filter. Okay, so for the filter I would like to have a shape, and it's going to be this one, rounded tab top right. So it's going to be something like this. And yep, now let's go to format shape. Let's go to shape, and the rounded should be only 15, and the style should be white. Okay, let's go to general, let's add a title, and the title is going to be filter, like that. And then we can have 18, and the background is going to be this color, and let's put it in the middle. Okay, now I would like to go to the effect and go to visual border. Well, not visual border. Shape is going to be style, and remove the border. So we have something like this. But let's go to effect, visual border, let's on, then it's going to be 15, and the color of the visual border should be white. Yeah, something like this. And I want to have a bunch of filter here, but wait, this is too big. Maybe 3 filters is enough. So where's my filter? So let's add slicer, and it should be something like this. So the slicer is going to be region. Let's go to slicer setting, and let's choose the drop down. And for the value, I want to have a white value, while the background is blue. Yeah, similar to the sales over time. I want to have a blue as my slicer, and so there's the value. But for this one, I also want to make it bold, like that. And let's add a background, something like that. Okay, so so now let's copy this. Okay, so now let's move this one here and this one here, something like this. And instead of region, I want to have category. Go something like this. And for this one, instead of region, I would like to have segment. Something like that. Yes, and finally I want to have a button, and let's choose a blank button. And here I would like to have a style and add a text, and it's going to be SuperStore, maybe 30, and it's going to be Georgia. Yep, something like that. And let's make it bold. And maybe the font color is yeah, kinda purple, something like that. Then let's copy this one, put it here, and then let's add sales dashboard. Something like that. But maybe yeah, maybe something like this. Okay, so SuperStore sales dashboard, and I want to go to here, and no, the button style, and turn off the border. This one also turn on the border. So I have my title here, maybe a little bit, something like this. Okay, so now we finish our dashboard. Or maybe, you know what, there's something I want to tweak. For this one, the slices of the biggest value of the slices should be also purple. Maybe this purple. Yeah, that seems good. So yeah, this is our Power BI dashboard. So now you can, of course, you can do some analysis using this dashboard, like maybe check the sales over time. Like you can see there's a lot of oscillation, etc., etc. And of course you can see the profit by the subcategory, by the sales by the region, and we can also see the total profit, the total sales, profit margin, total orders, and total quantity. So yeah, that's the Power BI sales dashboard. Now I would like to have my machine learning data in a Excel format, because it is an easy way to just export the data. So we can just go to data right here, and then you can click get data, and then choose from database, and then click from SQL Server database. Alright, now again enter the name of your server, and then click OK. Now this is similar to the Power BI dashboard, right? So again, you can go here to the SuperStore, and then we can click this view SuperStore data, and this is the data that I want to use for our machine learning data. So you can just click load. There you go, you have the data, we have the data. And then of course you can save this data and open the Google notebook for Google Colab notebook for the machine learning segment. Okay, so what is the order to ship estimation? It is a model that shows the customer when their order will be shipped. Like for example, after they order, and then they probably going to ask, when will my order be shipped? And by utilize the machine learning model, particularly the random forest regressor, we can answer that questions, and we can create a response such as your order will be shipped within 2 days. And then we are going to use the random forest regressor. A random forest is an ensemble learning method that combines the predictions from multiple decision trees to produce a more accurate and stable predictions. It can be used for both classification and regression tasks. In a regression task, we can use the random forest regression technique for predicting numeral value. It predicts continuous value by averaging the results of multiple decision tree. The random forest regressors work by creating multiple of decision trees, each trained on a random subset of the data. The process begins with bootstrap sampling, where random rows of data are selected with a replacement to form different training datasets for each tree. After this, we do feature sampling, where only a random subset of features is used to build each tree, ensuring the diversity in the models. We are going to create a model, but before we create a model, we need to one-hot encoding the features. So what is one-hot encoding? One-hot encoding is a method for converting categorical variables into a binary format. It creates new columns for each category, where 1 means the category is present and 0 means it is not. The primary purpose of one-hot encoding is to ensure that categorical data can be effectively used in machine learning model. Okay, now we are going to create the machine learning model for the shipping for the order to ship day estimation. So you can go to Google Colab. You can just go to colab.research.google.com like this, and then after you get into the Google Colab, you can just click File, and then you can go to your folder and just drag your machine learning data, your data for the machine learning. Okay, and then you can just click OK. Okay, now what you want is you want to click these 3 dots and then click copy path. You can just close it right now, and then first of all we need to import everything that we need. So let's start by import pandas. You know what, let's make it bigger, pandas as pd, and then let's import numpy as np, and then from sklearn.model selection import train, test, and split. Then from sklearn.preprocessing import one hot encoder. Then from sklearn. compose import column transformer from sklearn.pipeline import pipeline from sklearn.ensemble import random forest regressor, and then finally from sklearn.matrix import mean absolute error and mean squared error, and then let's run this cell. And also let's name this file shipping estimation, like that. Okay, now let's create a new cell and let's read our data frame. So we can say df or data frame pd.read underscore excel, and then you can just copy your path of the data, which is here, right? And then let's see the data. Df, you can use df.head, and then I want to see the first 5 row of the data. Let's run this, and now we get our data. Okay, so okay, let me do that. Then let make bigger, and then let's see the columns. Okay, so we have the row ID, the order ID, the order date, ship date, the ship mode, customer ID, customer name, segment, country, city, state, postal code, region, product ID, category, subcategory, product name, sales, quantity, discount, and profit. Now, before we get into further, I would like to create a copy of our data, and I just don't like to mess up with the original data, so we can just create data frame is equal to df.copy. Okay, so the original data is df, right? And then the copy data is data frame, and now we can mess around with this data frame without losing the original data. Okay, now let's clean the date data. Okay, and then you can just click Control and double M to make it a text, and then you can go to code again, and let's start to clean the data. So data frame, and I want to get the order date, the date data is equal to pd.to date time from the data frame of the order date. Okay, something like that. And then I also want to have similar, but now instead of order date, it ship date. Like that. Now the next thing that we need is the target. So what is the target? The target is the data frame, and let's create a new column called target, and this target is the data frame of the ship date minus the frame order date, and we are going to use days. Okay, so this is our target because we want to have an estimation between the order and the shipping date, right? So this is our target data frame. We want to calculate this target, right? And now after that, let's make sure that the target data frame has no negative value, because that wouldn't make any sense. Like if shipping date is before the order date, right? That doesn't make any sense. The order date should be first and then the ship date. So I want to have data frame is equal to data frame and then data frame of the target is more than or equal to 0. Why 0? Because it means that if it's 0, then the order immediately getting shipped, right? So we need the 0, we need the equal value. And you know what, I think target is not a good name. Let's call it shipping days, like that. Okay, now let's try to run this data, and we got an error. Series object has no attribute of DT days. PD.that time. Should be dt.days, not underscore days. Okay, so now let's try to see the data frame head. Let's see the first 5 row of the data frame that we have, and now we should have another column, and this column should be the shipping days. So for example, this order, he got order so the order date is 2016 at November of 8, and the shipping date is 3 days later, right? And that's what we are trying to calculate, and the shipping date is 3 days. So this is what we are trying to calculate, or this is what we are trying to predict, which is the shipping date. Okay, now that we have the shipping days column, let's create a feature engineering. Let me make it big. So feature engineering, and again let's make a title. Okay, so in order to work with the data data, we need to separate between, like, is it days, is it month, is it week, is it weekend, or like, so we need to have all of those information, because for example Sunday is not the same with Tuesday, right? Or Monday, that is definitely not the same with Friday, for example, because Sunday is a weekend, right? So there's something like that we need to consider while working with the date data. So we need to have feature engineerings in our date data. So let's start from create a data frame from the order day. Now we want to create a new column, and it's going to be order day, and it's going to be from data frame of the order date, order date dot dt dot day. Okay, and then data frame order month is equal to data frame order date and dt dot month. And you know what, let me just copy this. So this one is going to be order DOV. So DOV is the day of week, and then let's do this again, is weekend, and the data frame is from the order DOV, and instead of dt we get is in 5 6. Then let's change the data as integer. So what is going on here? So okay, let me do this. So what is going on here? Day of week will return an order date in a weekly data. So for example, Monday will be 1. Monday will be 1, and then Friday will be 5, and then 6 will be 5 will be, so okay, 5 will be Saturday, and 6 will be Sunday. So now we have a separation between what you call weekend and working days, basically. So 5 is Saturday and 6 is Sunday, and you can guess the number 1 is Monday, right? So that's why we need the day of week, so that we can find the weekend. Okay, and let's try to run this, and we got an error here, and it should be order date, not data. Okay, now what I would like to do is I want to have a feature selection. So I'm gonna select the features that I'm going to need. Okay. Let's start with let's see my columns. Okay, I have all of this column, and so let's start one by one. Okay, so I need a target, obviously, because I'm going to create a machine learning model, and the target is the shipping days, because this is what we want to calculate or to predict. And then I would like to have two separate features. The first feature is the categorical features, and the second feature is going to be the numerical features. Okay, so now let me try to see. So the categorical features should be the ship date, and then let's see the segment, maybe the segment, the region, and we need the state. We also need the category, and we need the sub category. No, okay, subcategory. We don't need the country because it's US data, so everything is just US. The country only has one data, which is the US. Okay, so that is the categorical features. Now for the numerical features, I want to have quantity, sales, and then discount, and then order month from here, right? And then I would like to have order DOE, and then order and then is weekend. Okay, let me do that. Okay, so that is my features, right? Okay, now let's combine all of these features. So categorical features plus the numerical features. Just concatenate the data, and let me, okay, so now I have the features, and I need to have the X data, which is from the data frame, and I would like to have all of the features, and then the Y data. Instead of the features, I would like to have the target. Okay, let's try to run this. Seems pretty good. So now let's see the data frame. The X should be, let's see the first three row. So this is the training data, and this is the target data 3. And as you can see, with all of this information, the shipping days, like for example, in the 0th index, the ship date is this date, and then the customer, the segment is a consumer, the region is south in the state of Kentucky with the furniture category, and the subcategory is bookcases with the amount of quantity of 2, the sales is this, and then the discount is this, or month, order DOE, and it is not in a weekend, and the shipping days is within 3 days. Okay, so this is basically the X is our training data, and the Y is our target data. Okay, now let's split the data into just do this, split the data, and I would like to have the X train and the X test, and then Y train, and then the Y test, and let's use the train test split, and I would like to have 80% of my data become the training data, and only 20% of my data becoming the test data. Okay, and for the shuffle I would like to false, or maybe true. Yeah, let's make it true, and then I think that's it. So let's run the data, and then after that I want to create a pipeline. So it's going to be the pipeline, and the pipeline is let's call it the preprocessor, and the preprocessor is column transformers, and then transformers is equal to something like this. So remember where we have the categorical and the numerical features, right? So I would like to transform those features, and I would like to differentiate the way I transform all of those features. So for example, for the categorical data, I would like to name it categorical, and inside this categorical, how I would transform my data. So in this case, I would like to use one hot encoder, and let's handle underscore unknown is equal to ignore to prevent an error, and then the categorical is from the categorical features. Okay, and then let's create comma right there, and then for the numerical I'm just gonna pass through. I'm not gonna do anything with the numerical data, and it's coming from the numerical features. Okay, so if you don't understand what's going on here, I would like to change every categorical features data into a one hot encoder. Okay, so the features is coming from here, so all of these features are going to be a one hot encoder data, while the numerical features like this one, I'm not gonna do anything with it, so I'm just using a pass through right here. Okay, and then let's try to run this, and if you want to see what happened is, let me so processor, and then you can just run And you can see here in our transformers we have two data, which is the categorical data and the numerical data. In the categorical data, we change the data into one hot encoder. With the if it's unknown, let's ignore that data. While in the numerical data, we're just gonna pass through the data. We're not gonna do anything with the data. Okay, so that's what happened. Now I would like you to see what our data look like. So we can have transform, let's call it transform data, which is the data that we have transformed, right? And then let's do pd dot not pd but preprocessor, which is this one, and then dot fit underscore transform. Okay, and I would like to transform the training data. Let's run this, and then you can go to transform data, and then you can run this. Okay, so we now got a information regarding our data. So now alright, I create a mistake here. So instead of ship date, it should be ship mode. Okay, so now let's try to run this again, and then let's run this. Okay, so it should be ship mode, not ship data, because I'm like, wait, what's going on? Wait, there's so many data. And then the head, and then split the data again, and then create the pipeline, the processor, and transform, and then the transfer data. Okay, so now we have our data, and it contains 9,992 rows with 86 columns. Okay, and in order for us to see the data, we can import scipy.sparse, and then transform data sparse is equal to pd.dataframe.sparse.from sp matrix, and it's going to be our transform data. And then you can see our data. Okay, so this is what our data look like. Okay, so it has 9,990 rows and 86 columns, and as you can see, all of the categorical data becomes the one hot encoder. Okay, okay, now let's create let's train the model. Let's train like that, and then let's make it okay, something like that. Okay, so first of all, let's create the model 1, and the model is going to be random forest regressor, and the n estimator is 100, and let's do max depth of 15, and the random the random state is 42, so we can have the same model, the exact same model, and then the end of jobs is equal to -1. Okay, so this you can tweak all of this value, you can tune all of this value later on if you think that your machine learning model is not good enough. Okay, so after that we create a pipeline, and the pipeline is going to be the pipeline of steps is equal to the preprocessor and then the model. So the model that we choose is model 1, and sometimes you want to use another model. You want to compare a couple of models, so it is actually pretty normal if you have model 1, model 2, model 3, or you maybe call it another name, but I always do something simple, just call it model 1, why not? And then finally the pipeline I'm going to train with the fit function, and it's going to be x train and y train. Let's train and let's wait. Okay, our model has done training, and as you can see our model has created a pipeline, and first of all it's going from preprocessor with the column transformer, and the category data is getting changed using one-hot encoder, and then the numerical data just pass through it and then the random forest, we use a random forest regressor model with all of this value. Okay, so now let's evaluate the model. Okay, let's do something like that. Okay, now first of all I want to create the prediction, and then it's going to be the pipeline dot predict, and I would like to predict the X test. Okay, and then I would like to compare the prediction and the actual data using mean absolute error and mean squared error. So the MAE, or mean absolute error, is going to be the Y test and the Y prediction, and then the RMSE is np dot the square root of mean square error of the Y test and Y prediction. And let's print the value, and the MAE is the MAE, and the RMS is the RMSE, like that. Okay, so now we get our evaluation. So what this number means? It means that okay, let me do this. The model predicts, okay, maybe instead of doing this, I can make it more clear. So let me do this and let me make it bigger, and it's going to be MAA. Let me round the value, and it's going to be like to have like this, and it's going to be this. Yep. Okay, so this is our data. So what is the error telling us? The model basically predicts the shipping duration with an average error of less than 1 day, and this is actually indicating a very reliable operational accuracy, because getting off 1 day is not a big deal, and it is actually quite accurate in the day-to-day work, in the real work, right? So you can say as a data analyst, indicating reliable operational accuracy, right? So this model is pretty accurate. So and we can use this model in our app, like for example, so that we can give our consumer an information about our shipping duration. Okay, now instead of evaluating, let's just compare with the real data. So what do I mean by that? And I would like to have the test result is equal to the x of test, and let me copy the test, right? So, and then I would like to have test result a new column called actual, and this is going to be the y test, and then the test result is, the second one is predicted, and this is coming from the y prediction. Okay, now the test result is a group by the ship mode, okay, with the actual and predicted, and then I would like to get the mean value. Okay, so okay, it's not, it should be like this result group by the ship mode, and then yeah, maybe this is correct. Okay, now we get our result. So for the first class, the mean value for the shipping is within 2 days, and our prediction also predicted in 2 days. The same day is also is not a big differences. Well, in the second class, it predict around 3 days, and we also predict around 3 days. In the standard class, it says that it's almost 5 days, and in our prediction it is also 5 days. So it is a really good model at this point. But now I would like to have another validation. You can say it's validation, and then let's do x_test that head, and then let's see the first 3 rows, and also the x dot columns. I would like to see the columns. Okay. Okay, so what you can do with this model? Okay, so let's say I have input data, and okay, now I already create this input data and original data. So basically the idea is that we have two customer, and the first customer is from our data. So we have the real data, the real shipping date, while the second customer is a new customer, right? And both of these customer have the same thing they brought. So they have they buy a furniture bookcase, and with the amount quantity is 6, with the same sales amount, discount amount, order amount added to away, and then each weekend is also the same value. But the ship mode is, this one is in the second class, while this one is in the first class. Okay, so, and this one is also, instead of from Colorado, this one is from the California. And now let's see if we have able to predict this data. Okay, so let me just run this this cell, and then let's create a prediction is equal to pipeline dot predict, and it will be data frame and it would be input data like that, and then because it will giving us an array, I'm just gonna take the first the 0th index. Days, something like this. Okay, so we have a predicted shipping duration. So in our input data, the prediction is within 3 days. Okay, and let's see the y test dot head, and as you can see, it is also from 3 days. Okay, so I'm actually taking all of this information from the input data from the x test in the first row, which is this index, which is the 7993 index. So if you look at the index, and if you look in the shipping days, it's giving us 3 days. So just like what we predicted, it is also predicting within 3 days. So the model is running smoothly. But now, instead of the input data, let's see the new customer. Let's see how long the shipping take place. Okay, so let's run this. Okay, so if you live in Colorado instead of not Colorado, but if you live in California instead of Colorado, if you choose the first class, instead of second class, and if your segment is home office instead of consumer, the shipping would be much faster. Instead of 3 days, you will have within 2 days is already being shipped. Okay, so that's the entire purpose of our model, and this model is going pretty good. And now you can actually give this model into your machine learning team or maybe your data engineering team, so they can make something from this model. The last thing what we are going to do with this machine learning model is to have a SHAP or Shapley additive explanation. So what is SHAP actually? SHAP is a game theoretic approach to explain the output of any machine learning model. It connects optimal credit allocations with local explanation using the classic Shapley values from game theory and their related extensions. Okay, now let's create our SHAP by continuing just inside our Google Colab. Now let's create a text, and I'm just gonna create a new segment called SHAP or Shapley Additive explanations, and then after that we can create a maybe I'm just gonna like that. Yeah, like that. Okay, so now first of all we need to extract our data, our component. So extract data and model from our pipeline. So in order to do that, we can go to remember the preprocessor that we have, and we can just do pipeline dot name underscore steps, and then it's going to be the preprocessor like this, and then we can get the model. Let's say the model 1, because we named it model 1 from the pipeline name steps model. Okay, so what's happening here? So in this part we are going to oh my god. Okay, so we are getting data from here, right? And then for this part we are going to get the model. Okay, so let's try to run this, and let's try to so remember that when we are dealing with our data, we actually using a transform. Yeah, we are using transformers, right? So when we get the data, which is this data, we're not going to be able to see the data. So before we do anything, let's just create something called x-test underscore transform and y-test, because we are getting the data from the x-test, right? And then the preprocessor dot transform. Remember, transform, not fit transform, and it's going to be x test. Okay, so we will gonna get a data from here, right? They are going to be transformed by the processor. Okay, let's try to run this, and then let's see the x-test.shape. Let's see the shape of this data, and then we get 2000 data, because remember when we get because we have around 10,000 data, right? And because we get the data from x-test, we actually where is it? when we split the data into the train and the test, okay, so the test size is 20%, and the 20% of the almost 10,000 data that we have is going to be around 2,000, right? So that is where this number comes from, which is the test data, right? And then the 12 is the amount of features, the amount of categorical data, right? The amount of column. And then let's compare it to the X transform. So the X transform has the same amount of row, but it has different amount of of column, because the X transform is one hot encoded dataset, right? So this is why we have more column compared to the X test, okay? Because inside of our preprocessor here, we are using the one hot encoding, which is right here, right? So this is the preprocessor, and we are using the one hot encoding for our categorical features. And this is why when we are using the processor here and transform the X test, we get 86 column, which is coming from the one hot encoding process. Okay, now so let's get the categorical features of the after the one hot encoding. So let me show you what I mean. Categorical. So this is going to be features names after one hot encoding. And then so let's say it's cat features, right? And then preprocessor dot name transformers underscore the categorical, and then dot get underscore features underscore names underscore out, and it's going to be categorical features like that. And then we can have, you know what, something like that. And then for the final features name so the features names is the list of the category features, this one, plus the numerical features. And what is numerical features? It is a list that we already created before, which is this one, right? And so let's see, and let's start to run this data. And then okay, so we have a, okay, should be named get features name out, should be feature, and then input features is not equal to feature names in features. Okay. Oh my god. Now you know what, let's see the features name. Oh, names. Okay, so this is our features name, which is coming from the one-hot encoding data, right? So for example, we have so we have ship mode, and the ship mode has 4 unique value, which is the first class, the same day, second class, and the standard class. So based on one column, we get 4 new columns thanks to one-hot encoding, and inside of each of this column will be the boolean value. It's either yes or no, it's either 1 or 0, right? So this is our features. Okay, now we finally get to SHaP, so we can just import SHaP, and while we are waiting, okay, it's done. So we can just call the SHaP explainer, and then it's going to be SHaP.tree, because we are using tree model, and then explainer, and then inside put inside our model, which is model 1, that we get from here. Okay, so we get the model from there, and then we just input the model inside the explainer. Now let's run this, and then let's create a sample for the performance, and it's going to be SHaP. Let's call it X SHaP, and it's going to be X test underscore transform. And okay, so remember we have okay, I'm just gonna close this. Remember that we have 2000 data from X test transform. We have almost 2000, so we actually don't need all of the 2000 data. Let's just say we need the 500 data. Okay, and then we can go, let's change the data type into SHaP underscore, let's call it SHaP dense, and then it's going to be underscore SHaP dot to array, like that, because so if you see the SHaP, it is in this kind of compressed data, compressed spare rows of sparse matrix. So we need to convert this data type into an array. Okay, so let's run this, and then after we run this column, we'll get something like this. Okay, so from this kind of data we get this kind of data, and this is what we can use. Okay, so okay, if you're wondering, the X SHaP dot shape is going to be something like this. So 500 is coming from the 2000 data, and from this 2000 data we just took 500 as a sample, and this is why it has 500 row, while meanwhile the column still stay the same. So we have 86 column just right here, which is again coming from the one-hot encoding process. Okay, so now let's just create our SHaP values, and it's going to be the explainer, which the our SHaP here, explainer. So explainer dot SHaP values of the X underscore SHaP underscore dense. Let's run this, and then explainer is not defined. explainer x something. Okay, let's run this again, and then we can wait. Fine, we finished the training for the SHAP values. Now what can we do after this is to visualize. Let me do this. Visualize the data, and there's a couple of visualization tools for SHAP. So as an example, we can do is SHAP.summary_plot, and it's going to be SHAP_values, and then SHAP_dense, and then the feature names will be features names. Let's run this, and we get something like this. Let me do. Okay, so we got something like this, right? As you can see, the ship mode is the category that affect our shipping, mostly has the most effect has the most effect in our shipping. So for ship mode compared to the other category. And then okay, so we can do another visualization. So let's take just one data. So before I'm gonna take one data, this is actually explain the entire data that we have. So we have 500 data, right? So we have 500 data here in the SHAP dense. So this visualization represent all of the data, all of the 500 data. And now I would like to have just one data as an example. Like for example, because we have 500 data, we can go through the 0 index, the index, or the 499 index, just to get a random data. So let's see. Let's see the very first index, which is the number 0 index, and let's create a visualization using SHAP force_plot. Okay, I'm not gonna lie, I don't really like this SHAP visualization, this force plot, but I'm just gonna show you how you can do it. Maybe you will like that. So it's going to be explainer dot expected value, and then SHAP values is going to be our value, our index, and then the SHAP dense is going to be our index. Okay, forgot the comma, and then the feature names will be the feature names, and then the matplotlib is equal to true. Let's run this, and we get this kind of visualization. So remember that we use the 0th index of our data. So this is the very first data, the very first order that we have, and based on that data we get this kind of value. So in this particular order, the average of from order to ship is going to be within 3.05 days. And then you can see this all of this value. Again, I don't really like this visualization because it doesn't really explain much. it looks fancy, I'm not gonna lie, but it doesn't really explain anything. Even I have a hard time to see what this visualization means. So the visualization that I prefer the most is something called the waterfall plot, and it's going to be like something like this. So let's again use the same data, use the same order, and then let's explain nation is equal to sharp dot explanation, and it's going to be okay. Let me do this, and maybe let me make so okay, it's going to be the values are the SHaP values, the index that we choose, and then the base values is equal to explainer dot expected value, expected value, and then the data is the x sharp underscore dense, and then it's going to be 1, not 1 but the first index, or the zero number, the number 0, the index 0, and then the feature name is feature names. And now we can do something like this: sharp dot waterfall underscore plot, and we are going to plot this, and the maximum display is 10. Okay, so what is the maximum? We remember we have remember that we have this amount of column. So we don't want to actually see all of the column. So let's just this is basically, hey, tell me the top 10 column that affect this model the most. Okay, let's try to run this. Features name are not defined. Features. Okay, so let's open this image again. Alright, now what can we learn from this visualization? We can learn that the average order for this the average time for this particular order is 4 days, and we can maximize the average order into 3 days with the ship mode as its biggest factor. Okay, does that make sense? As the biggest factor. So for example, this particular order, the person, our customer chose the ship mode as a second class, and the second class, if you can see, it will affect the data into 0.15. And so what does that mean, right? So if you choose this data, shipping mode the first class, it will increase the amount of from the time for the order and until to the ship, right? Until the shipping, order to ship, by 0.15. And the highest contributors is actually the standard class. If you choose the standard class, you will have something that really affect your order. So this telling us that the first class is the best one. The second class, well, it is the best, but it is the second class, but the standard class has the biggest factor, but also it is not the best choice. Okay, and then okay, I feel like that's it. You can okay, I'm gonna explain this visualization in more detail in the reports segment of this video. Okay, now we get to the reports. So I'm gonna call it sales performance report of US-SuperStore, and the table of content will have client background, executive summary, inside deep dive, sales trends, average order value, order count, product performance, regional result, order to ship estimation, and then finally recommendation. Okay, so first, the client background. The US-based SuperStore is a retail company that sells a popular consumer furniture, office supplies, and technologies across US client and customer. Established in 2011, the company has grown and expanded in the last few years. The US-SuperStore's book of business is providing a data spans in various dimensions and metrics, including sales, products, sales by region, and the company's discount program. Reporting to the head of operations, an in-depth analysis was conducted to evaluate the US-SuperStore performance over the past several years, which is 2014 until 2017. This comprehensive review provides valuable insight that internal cross-functional teams will utilize to streamline process and enhance the US-SuperStore's commercial performance. The key insights and recommendations focus on the following areas: the sales trend, focusing on key metrics of sales revenue, number of order placed, and average order value. And then the product performance, analyzing different product lines, market impact, and refund rates to inform strategic product decisions. And then the regional results, evaluating regional demand and product performance with regions to identify areas for improvement. And then finally, with addition of machine learning model for order to ship time estimation for their customers. And this is the Power BI dashboard that the team can use. Okay, so let's go to the executive summary. So the sales revenue analysis, let's start from there. So the revenue growth and peak performance. Every year, the sale has been consistently growing since 2014. In 2017, became the strongest year, with sales consistently growing each quarter as a result of the generating $354.9 million. And in the fourth quarter of this 2017 saw the highest revenue, which is 54 million in November 2017, making it the best performing periods. January and February always comes at the lowest, with around 800K in February in 2014, even though the previous the fourth quarter always has a good performance. And then quarterly insight and the seasonal trends, the Q3 and Q4 of each year typically show strong performance, likely due to a seasonal shopping trends and marketing efforts. The Q1 of 2015 started well with 23 million in January, but the revenue quickly dropped in February and then bounced back again in March with 23 million, signaling a fluctuative performance compared to previous years. And then the declining trend in Q1, the February has a steady but slow growing every year, while January is more fluctuative. January and February always become the lowest in terms of sales, but still have a growing sales every year. As an example, in January 2015, the sales revenue with around 666.7% compared to January 2014. The Q1 revenue decline suggests a major downturn, likely caused by external market conditions, reduced customer demand, or internal operation shifts. And the recommendation is the Q3 and Q4 consistently deliver peak performance, with Q4 2017 setting a historical high. Strategic investment in marketing, inventory, and major campaigns should be prioritized during these quarters to maximize returns. Despite the year-over-year growth, January and February remain structurally weak. Targeted early year promotion, loyalty programs, and post-holiday campaign are crucial to reduce revenue drop-offs after a strong Q4 performance. The revenue seasonality is predictable. Planning should align resources, staffing, and spend in advance, scaling up for Q3 until Q4 and optimize the cost in Q1 to protect the margin without sacrificing the growth. The fluctuation in Q1 indicate execution inefficiency rather than lack of demand. Smoothing campaign timing, consistent pricing strategy, and tighter operational coordination can reduce volatility and improve the baseline of performance. And now we get into the inside deep dive. So the sales trend, the sales growth. This is wrong. So this should be number 1 and this should be number 2, the sales growth. Okay, so the sharp growth in every Q4. Historically, Q4, which is October to December, has been the strongest quarter due to holiday shopping, Black Friday, Cyber Monday, Christmas sales. However, every year, the Q1 sales plummeted. In September 2016, sales revenue was around 70 million, while the previous year in the September is 22.27 million. This represents around almost 200 growth from last year's. Declining and growth throughout every year, with each of Q1 in every experience a start with downward trends. The Q1 start with an average sales of 134K in January, but then it goes lower in February with an average sales of 65K dollars. This suggests the customer retention, pricing, or product market fit issue. The tech sphere, it showed my tech sphere, but the US-SuperStore may need to strategize through marketing promotion or change in pricing. The Q1 and Q2, the Q2 has a lower value in average sales compared to Q1, but when it comes to a total sales, Q1 is higher, indicating a fluctuating behavior of Q1 and steady behavior of Q2. And then for the Q4, historic high, indicating a high demand from the customers. And then for the average order value, the sharp of AOV surge in Q1 2015, followed by the decline in 2016 and 2017. The 2015 saw the highest AOV growth, peaking at $800,000 in January 2015, to be precise. The peak of January of 2015 almost seems like an anomaly compared to other months. And then the AOV declined in every last few months. The Q3 until Q4 always decline in every year, with Q3 2015 being the worst with only $192K. And then for the long-term stable AOV may indicate the consistency of pricing plus product. Since March of 2015, the AOV has been consistently stable, no extreme fluctuation, with the highest AOV of 360,000 to be precise, in September of 2016, and the lowest is in February 2016, which is only $132. Over the span of 4 years, the change of AOV growth has been relatively constant, indicating a minimal changes in product pricing. And AOV in January 2015 is likely not a major factor in the decline of sales that year. And then for the order count, a clear seasonality. Order volume is consistently lowest in Q1 and peaks in Q4 every year, indicating strong and predictable seasonal buying behavior. The strong year-over-year growth both peak in Q4 and low in Q1 periods increase each year, showing sustained business growth rather than one-off spikes. Predictable demand pattern month to month changes within each quarters and relatively stable, suggesting mature and well understood customer behavior. And then the Q4 amplifies the growth. The Q1 resets demand. Q4 acts as a demand accelerator, promotion year-end spending, while the Q1 reflects as a natural post-peak slowdown rather than underperformance. And then we get to the product performance. And for the product performance, we start with the best and worst. The furniture category has consistently strong sales year over year, totaling $550 million, and it's the highest revenue generating category product overall. Within the furniture category, Riverside Palace Royal Lawyers Bookcase and Royal Cherry Finish has the highest sales with $30 million in total. The second category products in terms of sales are technology, with $320 million in total, with Canon Image Class 2200 Advanced Copier as the highest product that generates $23 million in total. And then we have the office supply with the weakest in terms of sales. It only generates $255 million in total, with the GBC DocuPine P400 electric binding system as its highest product, with $30 million in total. So based on the total sales, starting from furniture, technology, and then the office supply, these are the worst product based. These are the worst products. Executive impressions, indoor outdoor wall clock only generates $561. The Dell Slim USB multimedia keyboards only generates $125, and the Sanitaire Vibra Groomer IR commercial upright vacuums replacement belts only generates $13. And then for the AOV over time, the AOV peaked in January 2015 at $801,000, and with the furniture category being the biggest contributors with $154 million. The furniture category are the biggest contributors to AOV, with Riverside Palace Royal Lawyers Bookcase Royal Cherry Finish as the highest contributors to furniture, which is $6 million. The technology category comes next at $210,000 with more stable AOV, while the furniture has a fluctuative AOV. Meanwhile, the office supplies only generate $68,000. And then we have the AOV of furniture and technology are going up in January 2015, probably caused by a new product. The highest AOV product during this period was O'Sullivan Living Dimension 5 Shelf Bookcase with $5.50 million. The total unit consistent Q4 spikes across all the product categories, likely due to Black Friday, Cyber Monday, and holiday shopping seasons. The office supplies contributes the most with more than 23,000 units being sold, with staples being the highest product being sold with 215 units. This shows that the price of products in the office suppliers are much cheaper than products in furniture and technology. And then the furniture has sold 8,020 units, with key adjustable height table as most sold product, which is 74 units, and the technology has sold 6,939 units, with Kingston Digital Data Traveler 16GB USB 2.0 as most sold product with 57 units. And then we get to the regional results. The West region contributes the most to sales revenue for each US-SuperStore's product. There's 32.31% of sales are coming from the West region. There's 375 million in total, peak at December 2014 with 17 millions of sales, with California as the biggest contributors in the West region that generates 247.18 millions of sales. In contrast, the US-SuperStore sales have underperformed in the South region. So the South region is the name of the region, so it's the South region. Only contributing the 13.41% of total sales. Peak at October 2015 with 11.65 million, and Florida as the highest contributors with 72.24 million of total sales. The worst performing city is North Dakota in Central region, only contributing 87.78 thousand in total sales. But it seems like a new branch of the US-SuperStore because the record sales started in May 2017. Now, the Central region have a massive spike in 2016, right here, due to special occasion. So during the September 2016, Central region have a massive spike, and the highest sales product during the highest sales of product being sold during this period is bookcases, generating $33.72 million. And then finally we get to the order to ship estimation, our machine learning model. In addition to self-performance analysis, the US-SuperStores also requested me to develop an order to ship time estimator. The model that I developed that can predict shipping time with more than 86% accuracy, helping set realistic delivery expectations for customers and reduce complaints. Based on the US-SuperStore's customer service, customers often ask how long it will take from order placement until shipment. Currently, these estimated manually or using fixed rules, which led to inconsistent expectation and customer dissatisfaction. To address this, we built a data-driven estimator using historical order and shipping data. In order to build this model, we use several key factors, including region, ship mode, state, category, subcategory, quantity, sales, discount, order month, order weekend, and then shipping date. Okay, this should be in the next line. The estimator learned from historical order to understand patterns that affect how long shipping takes on average. The estimator prediction differs from the actual shipping time by less than 1 day, indicating a reliable operational accuracy. And if we look at the order deep dive, by using one order as an example, we can get an information regarding how much factors that influence the time for order to ship. As an example, Below is an example for random order. The predicted shipping is 2.2 days, which is here, 2.2 days. Maybe I'm gonna, can I show the value? Okay, and the average shipping time is 4 days, right? And the key factor is, I'm just gonna do this. Okay, so the key factors are shipping mode is the main factor here, shipping mode. In this case, the order using the first class non-standard ship, which around 1.9 days faster than average. The calendar and location effects are minor because month, order date, and state only shift delivery time by around 0.05 days. Most features have negligible impact, indicating a stable, interpretable model. This model concludes that faster delivery is primarily driven by shipping choice, not customer location or order timing. Now, for the recommendations, is first to capitalize on strong Q3 and Q4 performance, increase marketing spend, promotional campaigns, and inventory allocation in Q3 and Q4, as this quarter consistently generating the highest revenue. Replicate strategies used in Q4 of 2017, the peak period, to identify best performing products, campaigns, and channels. The planned major product launches or high value bundles toward late Q3 and or early Q4 to maximize seasonal demand. And then improve the Q1 performance by targeted strategies. Introduce post-holiday and early year promotion in January and February to counteract the seasonal demands drop. And then offer incentives such as loyalty rewards, limited time discounts, or subscription renewal to maintain the customer engagement after Q4. The shift part of Q4 momentum into Q1 by running carry over campaign, like for example the New Year's deal or Black to routine offers. And then address January and February revenue weakness. Okay, this should be for address January and February revenue weakness. Focus marketing on essential or repeat purchase products that are less sensitive to seasonal spending, and then test smaller targeted digital campaign rather than broad promotion to improve the ROI during low sales periods. And then finally, leverage year-over-year growth momentum. Despite the low absolute values, Q1 show a strong year-over-year growth, indicating long-term potential. Set a realistic but progressive growth target for Q1, and then focusing on percentage growth rather than absolute revenue.